Okay, here we are. Take a few seconds to make sure stream is working. Check the audio and pop out the chat. Let's see. So, hello, hello. If it's working. Hello, hello. All right, it's working. Very good. About the chat. Now we're going to look at the next question. Convert to base -2 medium. LeetCode 1017. We just did the 1015. That was pretty good. We'll open that one, close this one, and refresh this one. And convert to base -2. Given an integer n, return a binary string representing its representation of base -2. Note that the return string should not have leading zeros unless the string is 0. Excuse me. Okay. N is 2, -2 squared plus -2 first is 2. Oh man. It is exactly what it says. No kidding. Wow. Gee. Well, the every other number is going to be subtracted a value, right? Gee. Huh. Probably could use a kind of binary search on this. That's a very peculiar. I don't know. Let me get pen and paper for this one. I don't know. I don't know, man. Base -2, huh? Excuse me. Well, you could try base 2 and then convert that to base -2. I'm aware how to do that. Oh, my neck. Ooh. Body. Can I convert one of the bits in base 2 to something in -2? So you have -2 to the 0th, -2 to the first, 2 squared. Interesting. Well, really, your numbers are going to be a -1 or 0, right? It's similar to base 2, but yeah, -1 or 0 would make more sense. Sort of that would be the analog to base 2, but actually it's going to be 0 or 1. Oh man. Can you represent any number in this way? Excuse me. Excuse me. Well, let's say I want to represent 2 to the 0, 2 to the first, 2 squared, etc. Right? 2 to the 0 is equivalent to -2 to the 0. 2 to the first is 2 squared plus or minus 2 to the first, or minus 2 to the first, which is equivalent to -2 squared plus -2 to the first. And I think 2 to the, and let's say 2 squared is -2 squared. Interesting. 0 is just 0 times -2 to the 0. How about 2 to the n plus 2 to the 2n where 2n is even, it could be just negative 2 raised to 2n, right? And 2 raised to 2n plus 1, where 2n plus 1 is odd, gives you 2 raised to 2n times 2, which also could be negative 2 raised to 2n plus 1 minus negative 2 to the 2n, maybe. Or, excuse me, it could be 2n plus 2 minus, yeah, there we could do it that way. Okay. So you get 2 to the n plus 1 could be negative 2 to the 2n plus 2, which gives you a negative 2, which is equivalent to 2 raised to 2n plus 2, minus, or plus negative 2 raised to 2n times negative 2, which gives you 2 raised to 2n plus 2. Okay, so an odd value, 2 raised to the n plus 1, could be rewritten as negative 2 raised to 2n plus 2 plus negative 2 raised to the 2n plus 1. Yeah, which is exactly 2 raised to the n plus 2n plus 2 minus 2 raised to the n plus 1. Interesting. Okay. So if there's a particular, so each bit that I want, the even bits, I can take them as they are. The odd bits, I want to just take the, so yeah, I think I can convert a base 2 number to a base negative 2 in that way. I could just take the odd numbers, I could take them as, themselves, and the larger bit, the bit to the left. Now, what's odd about this is, let's say I had something like 3, right, or 5, right? 2 squared and 2 to the first. Yeah, 2 squared and 2 to the first, like 5, right? So it'd be like 1, 1, 0, or excuse me, no, 6, 6, 6. Something like 6, or maybe something like 6. That would be 2 squared in base negative 2 would be negative 2 cubed minus plus negative 2 squared, right? And then 2 to the first is just 2 to the first. Okay. But what if I want 2 cubed also, right? 2 cubed is negative 2 to the first is negative 2 to the first, and 2 cubed is negative 2 cubed. So it's not 6 that I'm interested, it's actually 14. How do I write 14? Again, that would be 2 cubed and 2 squared and 2 to the first. 2 cubed can just be negative 2 cubed, and 2 squared can be negative 2 cubed plus negative 2 squared, and 2 to the first could be negative 2 to the first. Well, the problem with that is if I have 2 cubed twice, that's actually 2 to the fourth in that instance. And it's even, so actually I can end up with, I could just do negative 2 to the fourth. So in my problem here, I can do negative 2 to the fourth plus negative 2 squared plus negative 2 to the first, which gives me 16 plus 4 plus 2. No, that's wrong. Nope. No. I did that. I don't know. I got confused. No. The even numbers are fine. The odd numbers are the ones that need to be modified. Yeah. So I think I had the right idea the first time. 1, 1, 0, or even, hold on. to the negative 2 to the 0, negative 2 to the first. 2 to the oh boy. The even numbers, I could take them as they are. The odd numbers, it's a little more complicated. So let's try to make things complicated, and let's just go for 1, 1, 1, 1, which is 16 plus, it's 8 plus 4 is 12 plus 2 is 14 plus 1 is 15. So let's try 15. 0, 1, 2, 3, 2 to the fourth, one more 1. That's actually 31. Let's go with 31. Okay. When considering 31, 2 to the fourth can still be negative 2 to the fourth. 2 cubed, which is odd, would then need to become negative 2 to the fourth plus negative 2 cubed, right? So we add a bit to the left side. Then, which is where things get interesting, 2 squared can be just negative 2 squared, and 2 to the first has to be written as negative 2 squared plus negative 2 to the first, which gives me 4 minus 2, which is 2. Yeah. And then finally 2 to the 0th is even. That one's fine. That could just be negative 2 to the 0. So I end up with 2 times negative 2 to the fourth plus negative 2 cubed plus 2 times negative 2 squared plus negative 2 to the first plus negative 2 to the 0th power. Yeah. Which makes things interesting, right? And does that give me 31? That's 2 times 16 is 32 plus negative 8 plus 4 times 2 is 8 plus negative 2 plus 1. And that gives me the 8's cancel. We get 32 minus 2 plus 1 is 31. Okay, so that's correct. Now, the problem is that I have to do something about this 2 times negative 2 to the fourth. Well, it's not the easiest thing to handle because I can't just go straight into negative 2 to the fifth, right? Because if I did that, this would become a negative number, which is not what I want. Now, I do want that amount negative 2 to the negative 2 to the fifth, but that could be represented as 2 to the sixth, or I do want negative 2 to the fifth. Or rather, I want 2 to the fifth. That's what I should say. So I want 2 to the fifth, which is actually going to be 2 to the negative 2 to the sixth plus negative 2 to the fifth. Yeah. So that's kind of how the bits shift in that direction. So I think I could use some dynamic programming to do this, but I have to be clever about it, however it is I do it. This is a good question. It's definitely kind of makes you think. And the same thing happens on the other side where I have 2 times negative 2 squared. That gives me an equivalent of 2 cubed, which is then should be rewritten as negative 2 to the fourth plus negative 2 cubed, right? And so I would end up with something like, I think, negative 2 to the sixth plus negative 2 to the fifth plus negative 2 to the fourth plus, I think, negative 2 cubed which actually makes things more interesting. I actually end up with 2 times negative 2 cubed plus I think negative negative 2 to the first plus negative 2 to the 0th. Which again is going to be 2 to the 6th, I think is like 64 minus 32 plus 16 plus negative 16 plus negative 2 plus 1, which, yeah, it does give me 32, 31, which is 31. This 2 to the negative, this 2 times negative 2 cubed, though, has to be reduced to, or modified to its, how would you express that one? That one is sort of like negative 2 to the 4th. Yeah, so I know what to do when you have 2 times negative 2 raised to 2n. That becomes like an odd number. Negative 2 raised to an odd number, and we can kind of, we sort of have a way to handle that already, or have an idea how to handle that. But when I have a negative 2 to the third, an odd value, that should be negative. That's a little bit strange. I don't know what to say about that one. I don't know what to do there. I mean, I can cancel these two. Actually, I think that's what I ought to do. I cancel it with this negative 2 to the 4th and this 2 times negative 2 to the 3rd. Yeah, those just outright cancel. That's a little weird. I don't know how you would express this otherwise. You basically just get negative 2 to the 4th, or negative 2 to the 4th. Well, subtract 2 to the 4th is what I should say. Yeah, this would end up just being 1, 1, 0, 0, 0, 1, 1. Base negative 2. This is not so obvious what to do here. It's really not obvious at all. I don't know. Let me try another example. So we had 3, right? If we want to convert 3, that's just 1, 1, to the first and to the 0. That would be converted to, I don't know, I mean, yeah, it's kind of not so obvious what to do here. I think I've just got to convert a bunch of these by hand and get an idea, get a sense for it. You could do negative 2 to the first plus negative 2 to the 0. That works. That's no, it doesn't work. No. Negative 2 to the first can only be represented at, not negative 2 to the first, it's got to be 2 to the first plus 2 to the 0. 2 to the 0 can be negative 2 to the 0. 2 to the first can be negative 2 squared plus negative 2 first. And there's no issue there. What about something a little more complicated, like I think 7, it would be 7. So now you have 2 to the 0 can be negative 2 to the 0th. 2 to the first can be negative 2 to the first plus negative 2 squared. And 2 squared can be negative 2 squared. So now we have negative 2 squared plus negative 2 squared plus negative 2 to the first plus negative 2 to the 0th. And now we have this kind of 2 times negative 2 squared, right? Which actually is equivalent to 2 cubed, which 2 cubed can be rewritten as negative 2 to the 4th plus negative 2 cubed. So now we have negative 2 to the fourth plus negative 2 cubed plus 0 times negative 2 squared. It actually disappears altogether, that term, plus negative 2 to the first plus negative 2 to the 0, which gives us 1, 1, 0, 1, 1. Right? 7 can be converted that way. But things get even more complicated when you consider like 15, right? Again, you can rewrite all of this as, I think going right to left is the way to do it. So you have negative 2 to the 0, then you have negative 2 to the first plus negative 2 squared to get negative 2 to the first plus negative 2 squared plus negative 2 to get to 2 cubed, you've got to use negative 2 to the fourth plus negative 2 cubed. 2 plus negative 2 to the fourth. And finally, negative 2 to the fifth has got to be negative 2 to the fifth plus negative 2 to the sixth. And this should be 15, right? So we get, this is negative 2 to the sixth is 64 minus 32 plus 16 minus 8 plus 4 minus 2 plus 1. That gives me 32. The 16s cancel. Minus 8 plus 8 minus 2 plus 1, which gives me 31. Okay, that's actually, that was 31. That was 1, 2, 3, 4, 5. Yeah, to the 0, to the first, to the second, to the third, to the fourth, and to the fifth. 0, 1, 2, 3, 4. Oh, wait. 0, 1, 2, 4. 0, 1, 0, no, 1, 2, 4, 8. 1, 2, 4, 8, 16. To the 0, 1, 2, 3, 4. I think I did this wrong. I don't know what I did. I did something wrong. Oh, it's so confusing. I'm also kind of like scrunched up over here the way that I'm sitting here is kind of awkward. It's a little weird. I don't have like a proper standing desk, so it's a little bit awkward for me to write. But anyway, 1, 2, 3, 4. To the 0, to the first, 2 squared, 2 cubed, translates to negative 2 to the 0 plus negative 2 squared plus negative 2 to the first plus negative 2 squared plus negative 2, I think to the fourth, yeah, negative 2 cubed plus negative 2 to the fourth. That's 16 minus 8 plus 4 again, minus 2 plus 1, 8 plus 4 plus 2 plus 1 is 15. Okay, and then if I go on the other side, if I go 5 ones, 1, 2, 3, 4, 5, then it's like negative 2 to the 0 plus negative 2 to the first plus negative 2 squared plus negative 2 squared plus negative 2 cubed plus negative 2 to the fourth plus negative 2 to the fourth plus 0, 1, 2, 3, 4. That's it. Yeah, 0, 1. Yeah, that's it. So you get negative 2 to the fourth plus negative 2 to the fourth plus negative 2 cubed plus negative 2 squared plus negative 2 squared plus negative 2 to the first plus negative 2 to the 0, right? And that's 16 plus negative 8 plus 4 plus negative 2 plus 1, 32, minus 2 plus 1 is 31. Okay. All right. Yeah, and then finally to get 63, You could add one more bit and keep going. But this should be kind of enough to see the pattern here. This -2 squared, these two will combine when you're looking at, was that 1, 2, 4, 8, when you're looking at 15. And those give you 2 times -2 squared, which actually could just be translated directly to 2 cubed, which then could be rewritten as 2 to the 2 to the fourth, negative 2 to the fourth plus -2 cubed. And then I already have both of those, so then I end up with 2 times -2 to the fourth plus 2 times -2 cubed. Basically, I could do all of these. I can perform these conversions moving right to left, is what I'm trying to say. And when I see a 2, it's either something that's odd, right? 2 times -2 raised to 2n plus 1. Or it's the other one, 2 times -2 raised to 2n. In the case of 2 times 2 times -2 to the 2n, that's equal to -2 raised to the, or excuse me, it's equal to 2 raised to 2n plus 1, which before I said we can convert that directly into base 2 with just taking -2 raised to 2n plus 2 plus -2 to the 2n plus 1. So that's no problem, right? That's not an issue. However, 2 times -2 raised to 2n plus 1 is a little more complicated, because it's a lot like we can swap, right? We could take a -2 out. -2 times 2 times 2 raised to 2n, or -2 raised to 2n, is then equal to -2 times 2 raised to 2n, right? Which we said 2 raised to 2n is, it's -2 times a -2 raised to 2n, which is then equal to -2 raised to 2n plus 1. Is that correct? Oh, no, there's an extra 2. Sorry, no, I got that wrong. I missed it, I lost a 2 somewhere in there. Excuse me, it's -2. Oh man, that's confusing. Hold on. 2 times -2 raised to 2n plus 1 gives me 2 times -2 raised to 2n times -2, which is then 2 times 2 raised to 2n is equivalent times -2, which is then -2 times 2 raised to 2n plus 1. Well, 2 raised to 2n plus 1, we said could be rewritten as, we have -2 times that. That could be rewritten as -2 raised to 2n plus 2 plus -2 raised to 2n plus 1, which then gives me -2 raised to 2n plus 3 plus -2 raised to 2n plus 2. Okay. Whew. Right. I see. Interesting. Interesting. Yeah. So I think I can use something of a frequency map as I go right to left. And basically place these digits where they need to go. Excuse me. Excuse me again. Yeah, very interesting. I don't know. I don't know what to do with this. I'm wondering if things should be canceling. That's kind of what I'm thinking about here. No? Huh. Interesting. Very interesting. Huh. The largest number is not going to be a negative number, because then the whole thing would be negative, necessarily. Yes, true. Well, I mean, this is one way of doing things, right? So if you have, for each 2 times, negative 2 to the, oh my goodness. For each 2, something greater than 2 times negative 2 to the 2n plus 1, that's going to be you could rewrite that in terms of negative 2 times 2 to the n plus 3 plus negative 2 times 2 to the n plus 2. And similarly, 2 times negative 2 to the 2n can be rewritten as negative 2 to the 2n plus 2 plus negative 2 raised to 2n plus 1. Yeah, okay. So if a is odd, you end up with negative 2 raised to the a plus 2 plus negative 2 raised to the a plus 1. And then if a is even, then it's negative 2 raised to the a plus 2 again, plus negative 2 raised to the a plus 1. Oh, is that the same in both cases? It is. Nice. Okay, that's easy. All right. Oh boy. This is quite a question. Oh man. Gee. Well, it's satisfying at least. It feels good once you figure it out. I don't know what to say about this though. It's just like freaking. Oh my goodness. Yeah. You go definitely go right to left. That's for sure. And what's going to happen is you're going to take oh man. I mean what do you do? What do you do in this situation? So you can do this with constant extra memory, I think, aside from the memory required for the answer. You only need to go like I think 2 bits ahead of whatever 2 digits ahead of whatever you're working on. Excuse me, because each digit only affects it's either itself and the 2 digits ahead of it, so you don't need to go that far ahead. And what you're going to do is you're going to look through. There'll be a few variables to look at. First things first, you're going to look through the binary representation of the integer that you're considering, and if there's a bit there, then it's either odd or even at that position. You're going to do different things depending on whether you're odd or even. You're also going to have a count of 3 variables, which is going to be, we call them like alpha 2, alpha 1, and alpha 0, where these are basically the counts of how many of the base negative 2 values you want at that point. So alpha 0 is going to be what you're looking at the moment, and then alpha 1, alpha 2 are going to be sort of in the future. Okay. When you see a base 2 element, if it's odd, or if it's an odd power, then you're going to want to convert that appropriately and increment alpha 0 and alpha 1 and alpha 2 appropriately. If it's not an odd value, it's an even value, then you increment alpha 2, alpha 1, and alpha 0 appropriately again. And the formulas are going to be, if it's odd, it's going to go to, well, if it's even, then you can just go straight and increment alpha 1 by 1. That's it, right? Or alpha 0 by 1, excuse me, alpha 0 by 1. That's where you start at. If it's odd, you're going to increment alpha 1 and alpha 2 by 1, right? Which means you're going to take, if it's 2 raised to the a, you're going to take 2 raised to the a plus 2 and add 1, and then 2 raised to the a plus 1 and add 1 to those spots. So you add alpha 2 and add 1 to alpha 2 and alpha 1. And then you process alpha 0, and you say, okay, depending on what alpha 0 is, if alpha 0 is a 1, then I'm just going to, if alpha 0 is a 0, I'm going to write a 0 to my my string in this spot, again, from right to left. If alpha 0 is a 1, I'm going to write a 1. If alpha 0 is anything greater than or equal to 2, then for each value of 2, so I could take it, divide by 2. So take alpha 0 mod 2 and write either 0 or 1 there, depending on what the modulo is. And then alpha 0 divided by 2, whatever that is, I'm going to add that amount to alpha 1 and alpha 2, right? So I'm going to take that divisor and then add those two values. And then I'm going to update alpha 1 to what alpha 0 was, alpha 2 to what alpha 1 was, and then alpha 2 is going to go to 0, right? I'm going to shift all of my 3 variables to the left after processing alpha 0. And, excuse me, and I'm going to do this for each digit that I see. And then at the end, if alpha 0 is not 0, right? Yeah. Well, so there could be more processing that needs to be done. Alpha 0 could be. So I don't know if it's possible for the alpha values to get larger than they should be, like very large. That's kind of what I'm wondering. I think, yes, each digit only affects the next 2 digits ahead, but you could get compounding where you have a bunch of stuff being added to the things ahead, to alpha 1 and alpha 2. I don't know if it's possible for things to go larger than 2. I could be wrong. I'm assuming it can't. If, I don't really know, actually. Well, the most stuff you could end up with is if just everything's a 1, right? And if everything's a 1, there's a little bit of like cascading type of a thing going on. So I'm getting at. Well, I don't think it's possible for any of these alpha values to exceed 2, the way that it's set up here. And if that's the case, then don't really need to worry too. You don't really even need a division, actually, to divide by 2, quite frankly. I think, okay, so let's assume alpha 0 can never exceed 2, right? Suppose it can never exceed 2. In that case, the most you could affect alpha 0 can never exceed 2. The most you could affect alpha 1 and alpha 2
from that point is alpha 1 is going to get could be incremented. Oh yeah, that's actually a good question. Regardless of what alpha 0 is, if it's odd or even. Oh, it's so confusing actually. Because what if alpha 0, if the bit is set to 1 and alpha 0 is 2 when you look at it? Yeah, so actually, yeah, these can go above 2, right? Because the bit could be set to 1 and alpha 0 at that point could be 2, right? Oh man. And then you have to increment the alpha 0 there at that point to 2, depending if it's odd or even. Oh, okay. Yeah, okay. All right. In that case, yeah, I had the right idea to use divisions and modulo operators and all that. But then what can happen is then you want to process alpha 0, alpha 1, and alpha 2 in a while loop without any bits afterwards until they're all zeros, until alpha 0 is 0. Yeah, and you just do another while loop to add more bits to the string. And so that will build the string from right to left, but strings are kind of built left to right. So you'd have to reverse the string before returning it at the end. That's kind of it. Basically it. I think that works. It's linear in the number of digits, which is logarithmic in the logarithmic in what they're looking for. That's a bit complicated, that's really involved. Excuse me. Oh man, my head is, oh boy, I've got a blood rush. Get kind of woozy, kind of dizzy. All right, so if n is 0, then return 0. Keep this simple. Excuse me, it's kind of a special case. Otherwise, we could say while n, right, n bit shift 1. And we can say if n and 1, result, n and 1, we have int, call them a instead of a1, a0, a1, and a2. And so if else is going to have a toggle as well. It's true initially. Don't do anything if the bit's not set there. We're going to say if odd, we do one thing, otherwise do something else. So if this is an odd power, no, so it starts off as false or even, let's say even power. It's initially even power, right? 2 raised to the 0 is an even power. If it's even, then we can just take a0 and increment it by 1, right? Because that means you can just take 2 raised to that, whatever that is, and make it -2 raised to whatever it is, and increment a0. Otherwise, it's an odd power, and you've got to take a1 and a2, right? You're going to take, if it's negative, if it's 2 raised to the third, you're going to take -2 to the fourth plus -2 to the third, right? That actually is 0 and 1. Is that right? Let me think about that for a minute. Yeah, 2 to the third, it's actually going to be -2 to the fourth plus -2 to the third, which gives you 2 to the third. Yeah. Because -2 to the fourth becomes 2 to the fourth, negative 2 to the third becomes minus 2 to the third. 2 to the fourth minus 2 to the third is 2 times 2 to the third minus 2 to the third is just 2 to the third. Yeah, okay. So actually, on the odd cases, right, toggle. On the odd cases, we're going to actually increment both alpha 0 and alpha 1, or a0 and a1. Now, where things get interesting, so again, we're going to update a0 to a1, a1 to a2, and a2 to 0. But what we're actually going to write to the result is going to be constant write, or just result dot pushback string to int. It's actually it's more like this. 0 plus a0 and 1, right? Yeah. Okay. Right. So that'll take mod 2. That'll take modulo 2. Dividing by 2 though is a little more interesting. So we're going to say const int amount is going to be a0 bit shift by 1 to divide by 2. And we're going to take a1 plus equals that amount and a2 plus equals that amount. This is what I was saying before. You would add 2 to the spot or add 1. So a plus 1 and a plus 2 are exactly an a plus 0, right? So increment a1 and a2 and then update. And then, shift everything forward. Yeah, something like this. And then finally, reverse the result. And return the result. Quite a thing. Should be logarithmic. Works here, doesn't work here or here. Oh, there's one more thing I forgot. Yeah, there's one more issue. So now while a0 is greater than 0, a0. I forgot about this. Also want to do this routine too. Basically run the same loop again. a0 or a1 or a2, right? While any of those are true. Don't have this anymore. We do have the same routine at the end. Yeah. If any of those are non-zero, there's actually more digits to add. I forgot about that. There we go. Yeah. Okay. All right, let's do like 1,000 and a million, 10,000 and a billion. 1, 2, 3, 4, 5, 6, 7, 9, 3, 4, 5, 6, 7, 8, 9 billion, and just a bunch of random stuff. Those are less than a billion. I don't know. You just subtract a few numbers there. Make sure it's not too big. Yeah, I don't know. See how these things go. Whew, gotta breathe. Nervous about this. Oh no, TLE, no. Which one, TLE? Not these ones, I know. 1,000 maybe? Uh-oh. Uh-oh. Gulp. Oh, it's 10,000? Billion? Maybe something else? One of these? I don't know what it could be.
All of them? Which one TLEs? The last one? Hmm. This one TLEs. All right, let's take off a few digits. Try to analyze this a little bit better. Try to get an idea of why it's TLE. Is it 598? Is that why? I don't know. I don't know what the issue could be. The 598 is fine. Add a few numbers to it. I don't know what the TLE part is. Okay. I don't know what could have happened. I don't know. Okay, so add a couple of. So 3822598 TLEs. Okay, well, the question is why? Why would that happen? This shouldn't execute too many times more. I mean, you delete A2 here. This kind of should, this basically should stop at some point. Like both of these should not go on forever. I don't know why it's TLE. Is this one the TLE one? Is this it? Okay. I don't know why that would be. I'm fairly certain these are all these are all, they should all terminate. They should all also complete in a relatively efficient time bound, like logarithmic 100, 290. Okay, so it's this one that's causing issues. Okay. Does it just loop infinitely? Why? It should all eventually be zeros. Huh. Something unusual going on here, something kind of subtle, hard to see. What is happening? Should all end up at zero at some point. And yeah, if any of them are non-zero, it should keep going, but it shouldn't ever go below zero. How does this happen? A2 ends up, what? A0 is A1, A1 is A2, A2 is 0. And then we say, okay, oh. How long does this go for? And why is it doing this? So, with this result, bit shift A, 0. A0 is 2, initial 3. A0 is 3. Get this result, we get A1 and A2. And then we add, we bit shift this amount. So we add 1 to A1 and A2. They become 2 and 1, right? And then we just shift down to 2 and 1. Then we add again 1 and 1, shift down to 2 and 1. And it just goes infinitely. Oh, let's see. Really? What? Why, huh? That doesn't seem right. Something seems wrong there. Something seems wrong there. I don't know what's going on. What? What am I looking at here? Huh? Huh? What? Okay, let me do it by hand. Something's not right. Something is odd, wrong. What is going on? What is going on? I don't know. Yeah, this is some kind of logical error, but what is it? I mean, it shouldn't matter that I have excess stuff in A0 because it should just all kind of shift over. What is going on? All right, so if I have -2, 3 times -2 raised to the A, and that gives me -2 to the A plus 2 times -2 to the A, right? And 2 times -2 to the A is equal to -2 to the A plus 2 plus -2 to the A plus 1, right? And that's always the case whether it's odd or even, the value of A. Yeah. Yeah, because you end up with -2 squared times -2 to the A plus -2 times -2 to the A. It gives me 4 times -2 to the A plus -2 times -2 to the A, which is then 2 times -2 to the A. Okay, that's correct. So that's fine. Basically, yeah, A0 ends up becoming 0, and we add these two values to A1 and A2. Just add 1 each, really. And if we already had something at -2 A plus 1, then raised to the A plus 1, then that would get incremented, right? That would get incremented. Does this go infinitely? Does this go infinitely if I see a 3? Yeah, that's really bizarre. Seems to just go infinitely if I do this. Well, that's weird. Yeah, because you get 2, 1, 0 goes to 0, 2, 1, which then goes to 2, 1, 0 again, and it just loops.
right. What? What am I supposed to do with that? That's weird. Very weird. Huh. I don't know. I don't know about that one. I don't know. Yeah. I think I'm supposed to cancel something at that point. Yeah, I'm pretty sure. Fairly certain. Yeah, basically you can't end up with a 2 at the end there. Or a 2-1. You can't end up with a 2-1. If you have a 2-1, you have a problem, right? Yeah. That's a problem. Well, if you're looking at 2-1, right? Negative a to the 2 times 2 plus negative a to the negative 2 to the a plus 1, that could and should be rewritten as 2 times negative 2 to the a plus negative 2 to the a times negative 2, which is 0. Yeah, that's negative 2 to the a of 2 plus negative 2. 0. I see. I see. So what does one do in that situation? I think you just stop, right? Yeah. Yeah. I think it's just you just stop. End up at 2-1-0. Interesting. Very odd kind of a thing. Very specific kind of particular thing, but that seems to be it. Yeah. Okay. So it can go for a little while longer, but then has to stop. And basically, yeah, if you end up in this situation, this is 0. These actually cancel each other out when you get there. But you can end up in a situation where you just keep trying to go infinitely. Instead of ever canceling it, you just keep generating more and more terms that all should cancel. Infinite number of terms that should cancel, which is it's quite odd. So yeah, it's an interesting question. It's a good question. Maybe not a great question for an interview though. I think I'd get destroyed if I had a question like this. It'd be kind of hard. Really hard to think this up on the spot. It's like really difficult. I think they might be designed that way. Quite frankly, I think they might be designed that way. I don't know. Maybe it's just me. Maybe it's just me thinks that they might be on purpose designed them this way to be. Oh no, it's still wrong. Oh no. Uh oh. So I finally got it. Wow. All right, here I am talking like I've already figured it out. Well, this one already tested. Let's go to the source. Let's copy this. Gulp. I don't even know the. I don't know, man. Gee. I don't know. Wow. Okay. What do you do with that?
So I forgot what I was even thinking or saying. I don't have it solved. Thought I had it. All right. Something else still something else here that I missed. Okay. What was the last one? So we have 10,000. All of these are fine. This two, these a billion and this other one. That's the problem. Or 1,000 even, really. 1,000 seems to be a problem. Just this one? Oh man, what a question. What a challenging question. Yeah, 1,000, okay. So, all right, let's try again. So yeah, whatever I did, I still don't have the solution. Oh man. There's also a situation where they cancel. Oh, all right. I see. Okay. If at any point A0 is twice A1, and you gotta stop. That's funny. What about does A2 matter at all? I don't know if A2 ever matters. I don't know. Try more things. Gee. Get really complicated, huh? Or these other ones that I had before. I don't know. Yeah, let's try these. Oh man. Oh man. It's quite a problem, huh? I don't know. I'm afraid to submit this. I don't know if this is going to be correct. Gee. Let's try some random things. Let's first go from 0 to 10. 0 to 10 and then 10 to 20 I think should be 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's do it that way. Oh man. Oh. Okay. Let's go 8 to 8, 9, 10, 11, 12, 13, 14, 15. And then start doing some just random numbers. Okay. Yeah, this is quite a question. It's quite a question. These might be a little large. I think some of those might be over a billion. Some of those may have been over a billion. I don't know. All right, I'm going for it. I'm going for it, man. It's been an hour looking at this question. Got there. Hell victory. Hell victory. I couldn't even tell you why it's correct. It's like, what? This is like a little ridiculous, this part. This is kind of silly. This is like, what? What? Also assuming that A2 is just not well, it's always 0 at the end of this. Yeah. So it doesn't matter what A2 is over here. That's important. Always set to A2 is always set to 0 anyway. so it's not a big deal. Yeah, I was gonna say, what about A2 over here? Okay, that's, I could tell you why it's right. That's fine. That's totally fine. That works. That's correct. Yeah, you don't need to process anymore when A0 and A1 cancel. Otherwise, you keep processing, and you don't need to do very much processing anymore either, because A2 gets set to 0. And the only time that this would loop more than a few times is because it's looping like infinitely. Okay, so that's logarithmic time overall. Uses constant extra memory. Always love seeing how others do these. What's up, Chip Jones? Welcome. Howdy. Hello. Did I talk about timestamps? 2:54. Okay, a few minutes ago. All right. Yeah, yeah, it's kind of cool to see other people's solutions. It's always unusual, different, because people come to think about things differently. I think I want to take a break after that. I wanted to do more questions, but let's see. Hold on. It's like 3 o'clock my time. Yeah, I usually submit it like 5 times. That's a reasonable approach. It's definitely like, that's a pretty hard approach, I think, to think up on the spot. It's a lot of pieces involved here. Could also actually optimize this slightly. Also, so A0 plus equals n and 1 and even. And actually, A0 is just always going to be incremented by this, right? And then A1 is plus equals this and not even, right? Could optimize this even further. I don't know if this is really an optimization, though. I'm assuming it is, right? Because that's all I'm doing is I'm modifying. This is happening in both cases. So this is really, right? That happens in both cases. And then this only happens when not even is the, this only happens when not even. And then both of these only happen when this is true. So you can just make that a check and then say add that to A0 and then add that to not even. I think that works. So you don't need to have any branches inside. Just curious if that'll work. That is not how I did this one at all. XD, yeah. No kidding. I don't know how other people did this one. I didn't even check to see or look. Yeah, I used a pretty well. Yeah. It's something I thought up, something I came up with. Okay, it's still pretty fast. Yeah, still reasonable. That's pretty funny. Yeah, just like a kind of an algebraic approach, I guess. I'll use a little bit of algebra, and then you can optimize a little bit with here and there. Okay. I'm gonna submit it one more time, and then I think I'm gonna stop there. I definitely need a break. That was a good question, though. That was a fun one. That would have been really hard for me to do it this way, like to figure this out. That would have been during an interview. It would have been like probably impossible for me to do that quickly. Yeah, I don't know what to say. Like, it's just, yeah, I use some algebra, but it is logarithmic time overall and constant extra memory, which is pretty good. It's pretty good. And I got the 100%, which is nice. So yeah, hail victory with that. And I think what I'm going to do is stop here. So normally what I would do is I would restart the stream with a different title and start another problem. But I actually want to just take a break. I don't know what I'm going to do for the rest of today. I've been programming for a few hours now. I just want to just kind of relax. That was a bit of a doozy. Few questions I had recently were like an hour each for me, and that was like just a lot of time, a lot of like trying to figure it out. So yeah, I'll take a break, and I don't know what else I want to say. Yeah, that's fine. Yeah, take a break. Okay. All right. If you like the stream, don't forget to follow. like the video too if you like the video. And yeah, I appreciate you saying hello and chatting in chat, Mr. Chip Jones. All right. Take care.